Hello, and welcome to the latest episode of GraphQL Radio. My name is Andreas Heiberg. I am the engineering manager here at Stellate. Today I'm joined by Charles Brown from Formidable Labs, as well as my colleague Jovi. Jovi is a prolific open source contributor, having worked extensively on Preact, as well as Urkel and many other projects. Jovi has been instrumental in building products here at Stellate, but before he joined us, he actually worked with Charles Brown at Formidable Labs. Charles and Jovi both worked extensively on the new platform for PUMA.com. Among their many achievements, the team managed to reduce their infrastructure costs by a whopping 30% by caching their GraphQL API with Stellate. Today, we hope to give you an inside peek at the challenges of building a platform that fits the needs of a global brand like PUMA. Yeah, obviously great to be here with you guys. I guess we wanted to discuss some of the work that Stellate and Formidable have been doing together on recent projects. And in particular, we've been working a lot together on PUMA, which I understand is most of what you do every day at the moment. Charlie, do you want to tell us a bit more about what you do for PUMA at Formidable Labs?
Yeah, so primarily I work on what I would call platform architecture. So my role is to look across our entire landscape of vendor tooling, the cloud that we use, AWS, to look at our React Native app and our web app and try to find better ways for all those things to interact and interoperate. So that is, sort of a hybrid architect, SRE, DevOps role, I suppose. And so I sort of float between the different applications and look for ways that we can, reduce cost, improve the performance, improve the user experience across the platform, and improve the ways that we can either debug things and get it fixed out quicker or roll out features to our consumers and clients faster.
Is there something you've been particularly proud of working on lately? Something that gets you excited every morning?
I don't think there's anything in particular since it's always a evolving thing, but I think we have worked really hard on optimizing performance for very specific parts of the application. And that is something that I'm really excited to see our teams work on. So that's a combination of, caching or optimizing the cloud or optimizing the way that our data is shaped in order to get that out, quicker. We've also worked a lot on how integrated we are with our backend systems, how GraphQL plays into that, and how that data is spread across the platform. So, in the beginning, you have sort of you build up fast, and let's say, we'll take any particular, so a product page, you start building and you have a GraphQL query of a specific size at some point. Let's say it's a product, a few fields, the color, the sizes of something. And at some point, you just keep building onto that query. And GraphQL will happily grab the data from various backends. It'll aggregate that all for you, and that's great. But as you keep building onto that, you eventually come across a scenario where you have 1,000 fields returned, right? And so your query complexity starts to get driven up very high. And you need to start looking at, okay, what can we do to this? Can we cache it? Can we split up this query into various things? So that might be, something you can do in the back ends, something you can do on the front end. And so looking into what we can do there and how we can break up that product story was the most important thing we've done, I think, over the past year.
Yeah, it's a very relatable problem. GraphQL is an awesome technology. It helps front-end developers so much, but it can be quite complicated to make that work from a platform and back-end perspective.
Yeah, Apollo provides some great tooling like data sources and data deduplication and request deduplication. But at some point, you're going to come across a scenario where I have highly cacheable data, like things like the product name, which are never going to change after it's produced. And then I have very uncacheable data, like inventory. And when you have those in the same GraphQL query, it's very difficult to optimize that query because now I have to decide, do I let my highly cacheable data just not be cached because my inventory can't? Or do I cache my inventory for a certain amount of time and now my consumers don't have an up-to-date look at, how many products I have left in my system? So you would then have to look at starting to split your query into several parts. What is content that I can cache all the time? What is content that I need to be real time? And what is something that's sort of in the middle that I'm willing to take a trade-off? I can cache this for a day or I can cache it for an hour. And those decisions will greatly affect the rest of your ecosystem because GraphQL by its nature is going to aggregate your many backend services. And, even in PUMA's ecosystem, that's some 30 different providers. So that downstream pressure that you're going to place on them without any caching up front is very high. If you get, let's say, launch campaign, we send a mobile app push notification out and everybody says, these shoes are amazing, I will need to check out those shoes. Well, suddenly you have 1 million new requests all incoming at once. And you need some sort of caching up front in order to protect your downstream providers from all that pressure they're now going to see. And when you are looking at splitting up your data into different GraphQL queries, it's very important to decide how you're going to split it based on that backend pressure, right? So if you take down your backend systems, you are going to take down your entire platform.
Yeah, it must be an amazing feeling from PUMA and I guess also your perspective to be part of something that is so exciting to people that they really want to take down your servers on launch day, right? But certainly it is very complicated to make that work. And I'm sure it has brought many frustrations over the years for you and the rest of the team. I guess you mentioned caching different sorts of data, right? Like you're thinking about caching and how can we kind of improve the performance. Like, what have been the real motivators for that? Like, what were the problems that you saw early on that you were aiming to solve with caching?
Yeah, when we first launched some of the new platform, we were in a single region. So Canada, North America region. And that was already a high volume region. And then when we started expanding out to new markets and new regions across the world, some of the problems we ran into is, first and foremost, cost. We looked at rolling out to regions faster than we looked at performance because the idea was to get out to those regions first, right? So costs started increasing as we added regions, not in proportion to the regions we're adding. So we needed to start looking into cost control. Second was our load capacity on our backends. Salesforce and various other backends are used, but at some point when you're using GraphQL and you start sending these great queries that the developers love to write, one request into your platform might be 7 requests into a platform like Salesforce. So you need to be very careful about the way that you're aggregating and writing queries at some point. The other thing we had was, as this platform became more popular with content managers, they decided, okay, we're going to send out more marketing emails. We can do this faster. So in the old platform, if marketing wanted to send something out, it might take, a week or 2 weeks for them to create a campaign and launch it. But now they can launch campaigns every single day. And so we were seeing spikes consistently across the platform, right? So mitigating the effects of all those things was the most important thing. We started looking at what I like to call the cache story. That is, what does caching look like at every piece of the puzzle across the entire platform? What does caching look like in the browser itself? What does caching look like from the mobile app's perspective? That's 2 different consumers hitting the same GraphQL. And then each of our backends, these vendors, they also have caching as well, right? They're trying to protect their own processes, so they have caching too. So when you add all these pieces of the puzzle up, you have a cache at this vendor and a cache at this level, and then you have, you're aggregating on GraphQL and you got some inter-process caching, and then you have caching in the browser, and it starts to become very complex to figure out where is my cache failing or where do I need to improve that cache, So it's an interesting puzzle to try to solve all those pieces together.
It's massively complicated, this world that we build on, but it's amazing when it works, I suppose. And most people would be none the wiser, right? The fact that when you buy your shoes on PUMA, that Charlie and the team has looked into all this stuff is kind of incredible, right? It's hard to really imagine for most people.
Right.
I suppose, are these sorts of challenges, do you see this with all the clients at Formidable Labs, or is it just unique to PUMA scale? Because PUMA is obviously quite a brand, right? I imagine there's quite the traffic going through PUMA's site. Is this more of a general issue that people are using?
I think you're right. Volume obviously is very important here. At a significantly lower volume, some of these caching problems can be put off further. The volume isn't really there and spikes aren't really as big of a thing, right? Most platforms, most companies are not going to have a 7 to 14 times volume increase when they launch a marketing campaign, right? So it's not really going to happen that way. We also have unique scenarios in the bigger e-commerce world, which is bot attacks. So bots will often try to buy up an entire product, go on eBay or whatever platform and resell those products. So that adds to that requests that we suddenly get a flood of, and that happens a lot with scheduled campaigns. If we send out an email that says 8 a.m. next week, we're going to launch a new product. Well, the bots, they schedule themselves to start working, and 5 minutes before that, you will see our traffic increase drastically for a while. So, part of that is like figuring out for every different client, what is the part that they need to cache and they need to worry about. If my client is at X scale or Y scale, each one of those can't necessarily use the exact same techniques the other one did, right? Like a smaller company is probably not going to afford or even have the time to implement like an AI protection against bots like we do at PUMA, right? So, that's what's important. That's where consultants come in this world, right? We spend a lot of time solving these problems for clients, and it's our job to like advise you which direction you need to go in these various pieces. So, everybody likes to look at a Netflix technical blog and say, well, Netflix did this, we need to do that. But Netflix has Netflix problems. And, most people are never going to reach that scale no matter how much we try, right? Of course, marketing and the business would enjoy that kind of, that capacity, right? But most people are not going to have to solve some of these giant problems, right? And even at PUMA scale, they're not Google scale, they're not Netflix scale either, right? So there's another jump and another level of things you need to start doing at those levels. So
I guess when you speak about bot attacks on like campaign launches, then there's a big trade-off going on for like how real-time is my data, because you probably can cache way less when there's this influx of requests and you need to be sure that you don't sell 7 billion shoes.
Right. When we have bot attacks, it's very hard to mitigate them because we are engineers and the people who write the bot attacks are also engineers. And any ideas that we often come up with to mitigate those, they know the ways around them too. And so, you have to use a lot of combinations of different parts to try to relieve that problem. Inventory is one of those, but inventory is the kind of system in a database where you have to start talking about concurrency and atomic writes and things like that, and that slows down your entire system. So in any given system, if your requests take 10 milliseconds and you only have the capacity to have 1,000 requests per second, when your inventory system is getting hit most often, that slows down your latency and then decreases the amount of requests you can take per second. So suddenly you have an influx of requests. Many of them are hitting inventory. So now your server latency increases and now you can't handle as many requests, and it sort of cascades, right? It keeps going down and suddenly you're at very few requests per second that you're handling. All of your requests are high, your inventory system's getting battered, and those are the scenarios that you spend a lot of time in the SRE world trying to solve, try to avoid.
You're just talking about the kind of different levels of investment you choose to make at different scales, right? Most people are not going to set up AI bot protection. I guess one of the wonderful things about the modern world is a lot of these tools are being commoditized, right? So you have like some Cloudflare. They'll give you AI bot protection. You just need to press a button, right? It's quite an amazing change that's been going on in the last couple of years. What are some of the tools that you're most excited about that have been commoditized that make it even easier to help your clients?
Yeah, I'm cautiously optimistic about the machine learning AI tools that are coming out now. I think in the content management world, they're pretty interesting, where content authors can write content a little faster. Cloudinary has some interesting new products where they can generate a video based on, you give them product information and they'll actually AI generate an entire video around that. I think those kind of offerings, those platforms are kind of changed the landscape a little. At first, it'll be a bit of a gold rush. Everyone is going to try to, we need AI or machine learning on our website, right? And that will kind of be a little chaotic for a while, but then people are going to start finding good reasons to use it, niches to use it. We're seeing this in the development world, right? We have AI tools now in our code editors that are helping us write code. So content authors are now seeing that. So if you're using like Sanity CMS or Contentful, or even if you're using tools just day-to-day stuff like Notion and Jira, you're starting to see those tools integrate machine learning into them to help people author new content faster. Can I write this marketing paragraph quicker? Can I get that out the door? Can I have a machine learning tool that is almost my editor, right? I don't need to send it around to 7 people to get it looked at and somebody misses punctuation, right? The AI tool's finding that for me. So I'm pretty excited to see those new tools come out, but also a little hesitant because I know that's going to make the engineering world a little bit chaotic for a while until we figure out where they really fit into everything.
You mentioned Sanity. How does Formidable and PUMA use Sanity?
Yeah, Sanity is a great CMS product where it's designed headless from the front and more or less schemaless. So content authors can design their content in any format they want, but more in a content-focused way. Instead of the older model of designing your content per page, you might have a page for a specific marketing campaign and you design your content in that way. They design content for content's sake. We have a cache of images, we have product information, category information, and then the site can then decide how it wants to piece that together and use that. So at PUMA, they use that for content authors can do everything up to rearranging an entire page in the order that everything appears on the page. Everything is built in slots. Everything is built sort of, I would say, horizontal segments across rows, I guess, of the page, and authors can rearrange those rows as they need. They can schedule content to run. I want it to run tomorrow only, and then another one replaces it. They can upload marketing banners and things like that, all in real time without, the previous way of involving an engineer, involving a Jira story, getting it in the sprint, waiting for it to deploy, things like that. Content authors are a lot more flexible now.
That's awesome. Sounds really powerful for these marketeers. It must have been very frustrating to have these very long lead cycles and suddenly everything is possible within the span of a day. That's really cool.
Yeah, in the marketing world, they care the most about how fast can they react. So all these tools we build are all about how quickly we can react. Long gone are these planning cycles where you need to plan a marketing campaign, you need to get it out the door. You really want to get some sort of campaign out there or product out there, get customer feedback as fast as possible, and then iterate and change on that as quick as possible. So content tools like this, like Sanity, help teams get it out there and iterate really quickly, because that's our changing market right now. A new TikTok campaign launches and a marketing team wants to take advantage of that. But you can't do that if you have a 2-week lead time on your content, right? So this allows people to just react a lot faster to what's actually happening in the market.
I guess you're a victim of your own success in providing all these awesome tools to these marketers. They're going to drive even more traffic to your website, right? So you're creating an even more challenging problem for yourself in trying to make that performant and scaling. How are you finding that? I mean, what are the challenges? You mentioned caching at the different layers, but is this kind of like a central learning for how you've been solving that problem?
Right. So we talked about how you can have a fresh cache, or relatively fresh, or real-time cache. You can have things that take a long time. And so when you have content that's authored, you now have to decide, is this content that I can cache for a long time, or is this content that I need to make sure I am never caching because it needs to change a lot? For example, if I have a marketing banner at the top of my site, I obviously can cache that for a very long time. But if my marketing banners decide that, well, this one's active for 3 hours, and then I want to change it in the afternoon to this other marketing banner, well, now I can't necessarily cache that because now it's on a date range. And if I cache it, the cache goes across the date range, right? And CDNs don't necessarily understand what date ranges do, right? We don't build a CDN that way. So now you have to decide, well, do I build some complicated process that looks at the date range that a content author set and it somehow ejects the cache at a certain time? Or do I have to sort of craft my TTLs in the CDN to react to that? These are all really hard things to solve. And so then you have to decide, well, maybe I send all of my campaign banners down to the website and I start filtering there on the client, right? And that can work too. But then smart bot people decide, well, we're going to read your HTML and we know you have 3 campaigns coming down, right? So people start to discover your products. This is something that happens often in the video game world. They don't want to announce a video game, but the website for Blizzard in the GraphQL request started revealing some new games that were coming out before it was even announced. So then people found out information. That's happened on Nintendo's product site as well, right? So you have to be careful where you start making those boundaries and those decisions, because there are real world complications involved in some of that.
That makes sense. I'm sure you also have lots of issues. I used to work for a company called Gelato, and one of the issues that we had was people combining coupon codes to get very cheap products. And then someone would find a system, a hack there, and they would post it on some forum, and suddenly our traffic would quadruple, right? And we'll be giving away a lot of product very cheaply. And so it's very interesting how ingenious people are.
I had a previous client that had gift cards. And the website did not require a login to check your balance or transfer the balance of one gift card to another. But creative hackers had figured out, well, if I just sort of brute force the gift cards, I can transfer a whole bunch of gift cards to my gift card, even if they're not mine. And so they just sort of, crafted the numbers. And so we had to come up with, a complicated set of rules to sort of block people from doing that. And we couldn't change the card numbers. They were sequenced, but they were actually physical cards that were handed to customers. So we couldn't change that, right? They printed 1 million cards in an exact numbered sequence and handed them out to customers. Now we started taking those numbers online. It's very easy to just increment a text box and just keep hitting a button and transfer cards, right? So there was like a real world problem that we could not change, and we had to solve it on the technology side. So that was a difficult thing to solve there.
Fascinating. In mentioning all these marketing campaigns, I'm just thinking through the flow, right? So, I'm a marketeer. I go and change some content on Sanity, and then I expect, true or not, I expect that it then shows up on PUMA.com, right? A lot of stuff has to go into that, right? As you mentioned, if you're caching stuff, you might have a TTL. It might take a day before something shows up, unless you do something, right? Which kind of brings the topic into purging. Like, how do you orchestrate all of this? I imagine it's a hugely complicated system you have on your side.
Yeah, purging is a very complex topic. So for one, in our world, any kind of mutation we send is not data we save in our own servers. Like, we don't control that data. All mutations go to some other vendor that we don't control. We cannot use a mutation necessarily to clear our own caches. We essentially have to ignore mutations for that purpose. And so in the times when we don't necessarily craft our cache rules correctly, we have sort of an escape hatch where our content authors can say, hey, this is not working for me. Hit the big red exit button and we nuke the cache. That's not ideal. And when that happens, we set up our DevOps systems to alert us to that when people are hitting that button. And then we try to figure out, okay, why did they need to? And we try to solve that with our CDN rules. But yeah, the reality of this is we have a lot of different teams that work together in various capacities. So we may not be as integrated in some of our teams, and they may change the Sanity content in a subtle way where caching has to then be changed, and we don't necessarily get alerted to that. We have to try to integrate and work together as much as we can. That's sort of the role of the platform architect. So making sure that I'm touching base with every team and I'm aware of those changes so that those things don't happen.
Jovi is obviously in an interesting position that he's writing a bunch of this stuff on our side, right? How do we actually think about purging data globally when someone presses that big red button on the PUMA side, right? How do we propagate all that data around the globe? I guess, Jovi, how are you finding that? It's obviously a very interesting problem. In engineering, there's like 3 hard problems: naming, caching, forgetting, and then off by one errors, right? How are you finding it to work on caching and in particular working on the CDN here?
It's in general an interesting problem because even on client side GraphQL, when maintaining Urkel, working on a normalized and a document cache is interesting. Then when we go to the CDN world, you have this kind of intersection between document-based caching and normalized caching, in the sense that at Stellate, we're operating a document-based cache. When a document, a GraphQL operation comes in, we'll look at the variables, we'll look at the operation itself and cache like that. But there's much more variables coming in because people can have owned data. We don't want user 1 to see user 2's orders. There's a lot going on. And when it comes to purging, I find most of those problems also pretty difficult to reason about, because let's say someone has a me query, you're just returning a user, then basically if that's not keyed, you're just purging everyone's user once someone's updating a profile, for example. It's hard to keep everything very cacheable.
Jovi brings up a really important point there, in that designing your cache keys is probably one of the hardest problems you will come into. So in our world for PUMA, the cache key is very complex because we have essentially a stateless server or stateless platform. We don't store any state. We don't necessarily know anything about a user. And we use OAuth to transfer the authentication around. But our backend systems, some of them are stateful. So understanding how to craft a key for our cache that is aware of the statefulness of our backends is very important, because that backend sees an OAuth token and says, okay, well, I can serve up this kind of cache data, like let's say customized pricing. So on our side, we need to make sure we have the exact same cache key, or at least most of that cache key, on our side as well. So they need to expose their cache key to us in a specific way that we can craft the right cache key on our side. So So the cache key we use is actually dozens of fields all combined into a single cache. And that's really important to get that cache key right. If it's not right, you could have users seeing each other's information, or you could have an over purge, which is less than ideal. You could purge everybody's cart, but you only meant to purge a single user, or you could purge product data for a whole category, but you only meant to purge one product. So it's very difficult to craft that key in the right way.
It's an age-old problem indeed. We spend a lot of time thinking about these things, and it brings us a lot of joy, but also a lot of pain. I guess what has been the journey that PUMA was on? So you obviously ended up using Stellate for GraphQL, but there's no such thing as just like, oh, I'm just going to use a SaaS provider and then it solves all my problems, right? Like it doesn't happen, right? We're trying to build tools that make it easy to cache GraphQL queries, but kind of in onboarding on Stellate, what were kind of the problems that you faced?
Yeah, so as PUMA started pushing this new platform to new regions and the volume started increasing, the other problem we've noticed with new regions was that not every region is equal in terms of latency and network. So we have Salesforce again as our primary backend, and Salesforce is only positioned globally in certain parts of the world, right? So if you were, let's say, running all your requests through the East Coast of AWS's platform, but it had to reach a server in Tokyo, the latency across that request is very high. Okay, and even if you are positioned somewhat near where the actual server is, you may not reach the edge network that's directly connected to that server, right? So if you're talking about countries like India or China, or most of Europe has various segments, right, and pockets where you could hit an edge network, but it's a very long latency to where the servers are actually stored. All those problems sort of start cascading as you bring on new regions across the world. For most consumers in the United States or Canada, you're always close to an edge network. You're usually close to a server, and we don't run into that problem when you're in the US. But the minute you start going global, that problem becomes very apparent. So when we rolled out, early testing in regions like India, we were seeing 7 to 12 seconds for a request in GraphQL, where in North America, we were seeing, sub 1 second. So clearly there was a problem here, right? And we started with, you can cache your backend, you can cache, in process itself in GraphQL. But at some point, you have to look at the whole global network and start thinking about where you can cache the best. We talked about Urkel, which has its own cache inside the browser. And that's great once you already have the data pulled down and you're navigating between pages. You're comparing two products. That's excellent. But to fill that initial cache, you need to make those requests. And so when you are looking at it from perspective of, let's say, a mobile app, your mobile app goes out, it's not going to get an SSR page like Next.js or something, right? And get that from a regular CDN cache. It's going to have to make all GraphQL requests. And when it's making those latency hops and you get it at 7 seconds on your mobile app, well, you start seeing really bad rating scores. No one wants to use your app. You don't have great conversion rates. And so what you want to do is, like a local browser cache, you want to put that cache as close to the user as possible. And so that's where Stellate comes into play. We wanted to essentially eliminate that gap. Stellate has edge networks across the world. You are closer to that edge network than you're ever going to be to our server. So you first hit that cache, and, using things like stale well revalidate and things like that allows us to, background update that request, still serve a stale request for a few seconds, and, essentially minimize. So I think even in our initial implementation where we hadn't quite crafted our Stellate cache rules perfectly, I think we went from something like 7 to 14 seconds down to 3 to 5 seconds. So even though it wasn't perfect, it wasn't ideal, it was a significant jump just with a simple implementation by moving that cache out closer to the edge.
That's quite tremendous. That's awesome. I'm sure that, from an experience point of view, like if you're sitting on your phone, the difference between 15 seconds and 6 seconds is an eternity, right? And we've all become so accustomed to these very fast apps. That's really awesome.
It's not something we could have planned for. I don't think anyone expected that we would onboard a new region and suddenly have 7 to 10 times slower traffic. No one saw that as a scenario. We just assumed it's the same code. Sure, it's geographically located somewhere else. So those aren't problems that you really think of, because even if you're looking at the country of India, geographically, it's massive. So where you live in India when you make that request and where those edges live is extremely important to that country, because, you cannot be in the middle and physically have that much distance you have to cross across various ages of telecom networks. Some of these things are very old. Some of them are fiber. Like when a request has to bounce across that kind of network with that many different pieces, it's not necessarily going to be performant.
Yeah, I've made this mistake in the past. You think, oh, how long does it take for the network traffic to go from my machine to China in my recent memory? So, it's like 200 milliseconds. Oh, it'll be fine, right? But you're forgetting the TLS handshake, right? So it's going back and forth multiple times in order to do the final thing. And this is how we end up in these like massive durations, right?
Yeah.
It's a fascinating problem.
Yeah, we are running a multi-region cloud as well. And that's not necessarily for redundancy or failover. It's just to co-locate our services with each other. So if we have a lot of back-end servers in one region of the world, we will place our AWS region there as well, and we route our edge requests to that region. So you're closer to it as you can be, because I was saying earlier that one request to our GraphQL backend might be 7 or 8 requests to various other backends, right? And not every single one of those backends has something like regional. We have many vendors that exist only in one part of the world. They don't have CDNs. They don't have edge networks. So we may have a consumer that is in India and our closest server might be Tokyo, or depending on the edge network they hit, maybe they will get routed to, like Frankfurt or something. But a vendor we use happens to be in Mexico. And so we still end up with a request that's hopping across the world sometimes. And, again, that's where cache is still really important, because we can't necessarily control the vendors we have to use. Every region has different payment providers. Every region uses a different product information system. Every region uses different CMSs. So we try to smooth out those differences essentially at the GraphQL side.
That's awesome. In summary, you're really able to help users, globally as well as in the US, but really dramatically change the performance of like, I want to buy my PUMA shoes right now. It's quite a crazy change, right? 12 seconds to 6 seconds initially. I'm assuming you got it even better now. Well, how's the app performing now?
The mobile app, which is a React Native app, is incredible. Between various caching we do right there on the client and GraphQL, the performance is incredible on the mobile app. On the website, we have more data because we try to do more on the pages. We have more marketing data. We have more analytics data that comes across. The performance is still excellent there, but we still have some challenges we're looking to solve in some of those ways, right? Because, the website's constantly updated. We have a large engineering team that's constantly adding new features. So then we have to react on the platform side to like, okay, now we need to cache that in a different way or things like that. So video is a new thing. Most e-com sites are integrating video across platforms in different ways. So making sure that we are caching and protecting that video correctly as well, right? So that's a big one.
So is it only users that are benefiting, or has there been other benefits and the performance increase?
Yeah, it's not just, cost has been a huge factor for us. So as soon as we implemented caching, the requests that actually hit us have gone down significantly. So that's also really important. Load capacity too. So we want to bring on more regions. As we roll on the rest of Europe, we're going to get more users per second, per minute, per day. And so we need to make sure that we can handle those, as well.
Yeah, I guess that's a big factor, optimizing the reads so you have more time to deal with the writes.
Yeah, I imagine on your side, Jovi, that that's sort of a bigger problem too. Like you have these edge networks out there and you can't necessarily clear the cache across the world instantly, right? You have to send out requests and each edge server also has to clear its own thing internally, right? So that's probably a problem that you also have on your side, right?
Yeah, I mean, how for Stellate specifically we solve it is every app has like a little ID that we encode into the surrogate keys, and we can do a request and that will end up at a local POP and that will start spreading across the globe. And it should be within a second that everyone's cache for like a certain app is invalidated. But when you're talking about that much keys, I'm not sure about the guarantee. I've never tested that.
Yeah, it's amazing to think about where we were, 10, 15 years ago, where something like edge networks spread across the globe was a very unique scenario that only specific companies were doing, right? It wasn't just you couldn't just open up Fastly or Stellate and have a CDN the next day, right? That wasn't a thing you could do that long ago. So it's pretty amazing that in a global network, we can do something like clear all caches across the world in 1 second. That's just, it's wild that we can say that today, I think.
Yeah, it's also really cool that all of in the start you had like a simple CDN that's like, oh, I can cache my textual content, my HTML page, my images. But like now they're programmable. You can do anything you like. I think the future there is very bright. Like being able to localize your apps everywhere in the world, maybe someday have performant databases on every edge location. That would be very impressive.
Yeah, it gets more interesting now that people are launching out things like a Rust worker on your edge, and things like that. So now you get into the scenario of like, okay, now I'm deploying code to a CDN globally, right? And am I running version 1 of this code? Am I running version 2 of this code for a brief moment as they switch over, and the complications that involves as well?
Yeah, the edge compute, it's very intriguing, right? But yeah, there's some very real complications there. Purging, I think Fastly has more than 100 POPs, right? Like points of presence. In any one of those, you probably have hundreds of servers, right? So when you go and you say, I pressed a big red button, I want to update this blog post on PUMA, it's like talking to thousands potentially of servers to go and purge all that content and update the cache, right? It's a massive feat of engineering. And it's incredible that any of it actually works, but it's wonderful that it does.
Yeah, and it's becoming more complicated now that React server components are starting to see some pickup, with Next 13 and people talking about, first we just had all client side and we worried about network requests, right? And we had some HTML, we had some JavaScript files, and we cached those in a CDN. But now we're caching an SSR page as well, right? So we're rendering all of our data. Now we're caching a whole rendered thing with its data. And then now we're going to start saying, well, what if each part of the HTML can also be rendered and then re-rendered and sent down individually with server components? So it gets even more complicated then. Like, how does that caching scenario work? When I hit my server, do I also go through a GraphQL, CDN as well? Or do I get the freshest data because that's in a cache already? Do I double cache? It gets even more complicated in those worlds now. So it'll be interesting to see where server components plays out in all of this.
I personally think we'll see a reduction in like caching the page itself and like focusing a lot more on the data, because with React server components, we'll have a distinction between it's rendered on the server or it's streamed down, because React server components could be your leaf, it could be your parent, and the rest will be streamed. So for all those streamed parts, you probably want very optimized data.
Yeah. And that streaming is interesting that you say that, because, now there's like stream and defer directives in GraphQL. All right. So now we have to decide, are those things that you can cache? Can you stream them? Does your CDN support streaming from it? Things like defer, where it's going to end up being 2 responses. Now we have to integrate things like that into Urkel, into other client libraries like Apollo. Those are all going to start making more interesting conversations as well, right? And subscriptions, I think, is another world where not everybody's using that type of functionality in GraphQL, right? Subscriptions isn't really out there too much yet, or people are using it for very small use cases. And so when that starts coming out, then you have a problem too, right? How do you deal with large amount of client requests when there's subscriptions involved, right? So yeah, it's a pretty wild world as we all shift to different components now again, right? It seems like a roller coaster. We're kind of flat for a couple of years. Now we're like, hey, exciting new stuff. And then we all have to figure things out again for a while.
Definitely can jump on that bandwagon. For Urkel, we've tried to implement the first stream, kind of stable now. And it's always interesting to think about how in the future that can be integrated, like with suspense, like can different fragments be like suspense boundaries themselves? Yeah, it's very interesting to see how this will all play out. Because I think definitely for server components and like the whole stream story, how it best works together with GraphQL is going to be a learning journey.
Right. And I think, Urkel is also a really unique case too, where, usually you have an Urkel client in your React app and it's making the GraphQL request for you. But now you have the SSR world or even SSG. You don't necessarily ship Urkel down all the time, right? You can choose to just have it in your SSR side or your SSG side. And so you don't ship Urkel as a client. You're using it mostly as a Node.js server component. So it starts to like blur the lines a little bit more there. And then people now have to make the decision. Do I ship all that down? Do I just keep it on the server side? Do I use something like Next.js or Remix where I'm letting the framework itself make requests to the backend? Or do I allow Urkel to make the request to the backend? And so the waters are a little more muddy now. And it's important that if you are a new startup or even you're an old engineering team and you're looking at these new technologies, to have people who really understand these technologies on your team. Otherwise, those decisions, they're already hard for those of us who've been doing this for a long time. They're even harder if you're just coming into it today, if you're just learning these technologies today.
Yeah, I think it's a difficult problem to solve. In my head, I always like to think of like when you have only a web app, it's probably ideal performance-wise to like have server components and all that stuff. But once you have like a mobile app, potentially like a web, like a tvOS app and so on, GraphQL becomes more and more appealing.
Right. You could skip GraphQL altogether, right? And just go to your backends with, like static rendering or something. And
yeah.
But yeah, as soon as you go out to 5-6 clients, as soon as you want a product catalog that's exposable bidirectionally with your CMS or something, then it's like, okay, well, now I can't just do all this in Next.js. I can't do all this in Remix, right? I have to also have GraphQL. So at that point, you either choosing between dual work or just using GraphQL for everything at that point. So you have to kind of look at the whole landscape. I would say that most larger clients are going to be served best by GraphQL because they're always going to have multiple consumers. I don't think we've built any e-commerce platform for a large client in years that didn't have that. So I don't think that's where Next.js built-in tools are going to fit, but they're great for, I can generate my content. It's amazing for SSG. It's great for SSR in scenarios where your data doesn't change as often. Then I would probably reach for that first, but yeah, GraphQL is still extremely important when you start looking at the enterprise picture and you need multiple consumers.
Fascinating. I enjoyed that back and forth. I think sadly we've hit time. Yeah, this is my first experience here. Looking forward to seeing the product. It seems like a tough one, but I enjoyed the latter half of this conversation. Thank you very much, both of you.
Yeah, thank you for inviting me.
It's a pleasure talking to you. Before we leave, is there anything that you want to discuss, Charlie, that we haven't touched on? Is there any burning desire?
No, I think we went back and forth, but it was good to see Jovi again.
It's been a while.
Yeah, we do chat sometimes in Slack or something, right? And I'm looking forward to definitely seeing what else we can do with Stellate in the future. I think we only cache a small percentage of our requests at this point, like something like 20%.
30, yeah.
Yeah, it's pretty low. And even with that alone, we've seen massive improvements. So, we're working hard to start architecting what we're going to do in the future with Stellate and Next.js and all these different technologies that we've integrated.
Yeah, we have lots of things coming down the pipeline. we're improving soon the latency for non-cache requests. So that would benefit you guys quite a lot, right?
Right, definitely.
Thank you, Jovi and Charles, for sharing a small glimpse into the story of how PUMA.com got made and the many challenges of building web services at scale. I feel like we only scratched the surface today, but I enjoyed the conversation and hope to hear more another time. In particular, I would love to hear more about the place of GraphQL in a world with React server components, and I hope to see you guys in the future. Bye!